Hi dear students, this is second video on noise pollution. In the previous video we discussed on what is sound. We have given the definition for noise pollution, and then we discussed about the decibel scale where the loudness of sound is being defined. Then the sound level and human perception of various day-to-day activities was also being discussed. Then the frequency and intensity of sound and how to measure that in a logarithmic scale with the unit called bell or decibel was also been discussed in the previous video. Now let's focus on the hearing mechanism and also the various sources of pollution and what are its decibel levels. In simple terms, noise is unwanted sound. So sound is a form of energy which is emitted by a vibrating body, and on reaching the ear it causes sensation of hearing through nerves. So all the sounds produced by the vibrating bodies, or the sounds produced from all the vibrating bodies, they are not audible to human ear. So the frequency limits of audibility for human ear, it varies from 20 Hz to 2000 Hz. A noise problem, it generally consists of three interrelated elements. One is a source, another one is a receiver, and the transmission paths. So depending on these three, we can control the problem of noise pollution. So now let's discuss the mechanism of hearing. Our human ear, it has got three parts: the outer ear, the inner ear, and in between comes the middle ear. Hearing starts with the outer ear. When a sound is made outside the outer ear, the sound waves or vibrations, it travel down the external auditory canal and it strike the eardrum, which is also known as the tympanic membrane. The eardrum then starts vibrating, and the vibrations are then passed to three tiny bones in the middle ear called as ossicle. The ossicles amplify the sound. They send the sound waves to the inner ear and into the fluid-filled hearing organ known as cochlea. So once the sound reaches the inner ear, they are converted into electrical impulses, and the auditory nerve sends these impulses to the brain. The brain then translates these electrical impulses as sound. The oscillations or sound are identified and interpreted in the human brain, which has capacity to analyze the sound in different frequency. The human detectable frequency, as we already discussed, it comes in the range of 20 to 20,000 Hz. Sensitivity of the ear, it varies from person to person. And as the person gets aged, the hearing power decreases. So with aging, hearing power decreases. So the ear is susceptible to damage if it receives high intensity noise. So that is the significance of noise pollution, and we need to control this noise pollution either by controlling the source or the path to which it get transmitted and this get received our human ear. So when by controlling these three elements, we can control to a greater extent the noise pollution.
Objects. The vibrations of a sound source cause the surrounding air molecules to move back and forth, creating a series of alternating regions of high and low pressures. A sound wave is basically a pressure wave. It propagates in the form of fluctuations in air pressures. The loudness of a sound is determined by the amplitude of sound waves, which represents the strength of vibrations produced by the sound source. The stronger the vibrations, the higher the amplitude of sound waves, the louder the sound. The pitch of a sound is related to the frequency of sound waves, which indicates how fast the sound source vibrates. The higher the frequency, the higher the pitch. Frequency is measured in hertz. A young human ear can detect sounds in the range of 20 to 20,000 hertz. Some animal species can hear frequencies well beyond this range. Hearing is the process by which the ear transforms sound vibrations into nerve impulses that can be interpreted by the brain as sounds. The human ear has three distinct regions, called the outer, middle, and inner ear. The outer ear funnels sound waves through the auditory canal to the tympanic membrane, also called eardrum, which separates the outer ear from the middle ear. The eardrum is attached to a chain of 3 small bones in the middle ear, called the ossicles, the malleus, incus, and stapes. Sound waves cause the tympanic membrane to vibrate, and the vibrations are transmitted through the 3 bones to the oval window, where the inner ear begins. Since the eardrum is much larger in area than the oval window, the sound pressure that arrives at the oval window is much greater than the original pressure received by the eardrum. This amplification is essential for the stapes to push against the higher resistance of the fluid in the inner ear. The organ of hearing in the inner ear is the cochlea, essentially a long tube that is coiled up in a spiral to save space. The cochlea is composed of 3 fluid-filled chambers. The central chamber, known as the cochlear duct, is where mechanical vibrations are transformed into nerve impulses. There are 4 rows of hair cells within the cochlear duct, supported on the basilar membrane. The movements back and forth of the stapes push on the fluid in the cochlear duct, causing the basilar membrane and the hair cells to move up and down. These movements bend the cilia of hair cells, opening the mechanically gated potassium channels on their surface. Influx of potassium depolarizes the cells, stimulating them to send nerve impulses to the cochlear nerve and on to the brain. Our ability to differentiate sounds of different loudness and pitch depends on the ability of the cochlea to respond differently to different amplitudes and sound frequencies. Louder sounds cause more hair cells to move and generate greater nerve signals to the brain. Different frequencies stimulate different parts of the basilar membrane, which acts like a set of piano strings. The basilar membrane is narrowest and stiffest at the base, near the oval window, and widest and most flexible at the far end. High-frequency sounds with more energy can move the stiffer part of the membrane, while low-frequency sounds can only move the more flexible part. Thus, high-pitched sounds excite nerve fibers that are closer to the oval window, while low-pitched sounds send signals through the fibers at the far end.
The intensity of sound is measured in terms of sound pressure level, and the common unit of that is decibel. We have seen the definition for decibel, and decibel, it measures how much intense a sound is as compared to the reference intensity. So the sound pressure level, it can be expressed in decibel. It's a pressure level of a sound measured in decibels. It is equal to 20 times the log base of 10 of the ratio of the root mean square of sound pressure to the reference of sound pressure. So the reference of sound pressure in air, it comes to be 2 into 10 power minus 5 Newton per meter square, or it is 0.00002 pascals. Or in other words, it's a ratio of the absolute sound pressure against a reference level of sound in the air. This principle is used for designing the sound level meter. So the noise level in decibel is measured with the instrument called the sound level meter. It consists of 3 internationally accepted weighing network. The weighing network are electronic filter circuits built into the meter to weaken certain frequency. They permit the sound level meter to respond more to some frequency than to others, which prejudice something like human ears. There are 3 weighing scales: A weighing scale, B weighing scale, and C weighing scale. So A weighing scale, it severely filters the frequency. It severely filters the frequency, whereas B weighing scale, it moderately filters the frequency. On the other hand, the C weighing scale, it hardly filters the frequency. So based on how it is filtering the frequency, there are 3 weighing scales: A, B, and C. As we discussed, the sensitivity of human ears depends on the frequency or pitch of the sound. So we hear some frequency better than others. For example, if a person hears 2 sounds of same sound pressure but different intensity, one sound may appear louder than the other. This happens when we hear high frequency much better than the low frequency noise. So in the case of A weighing filter, the weighing filter of scale A, it adjusts the measured sound to sound level to corresponding to the peculiarity of the human hearing. It filter out low frequency of pitches. So that is the peculiarity of A weighing scale. So let's see the different sources of noise pollution. The main sources of noise pollution include the traffic noise, noise from the industrial and construction machinery, then the public address system, the household activities, and various defense exercises. All these are main sources of noise pollution. So let's consider the traffic noise. The automobile revolution in urban areas have provided to be a big source of noise pollution. Increase in traffic has given rise to traffic jams where the repeated honking or hooting of horns by drivers create noise pollution. And the aircraft, so other modes like aircrafts, they create serious problems. And in India, it creates a major problem in cities like Mumbai and Delhi. Traffic noise accounts for most polluting noise in cities. So for example, a car horn, it can produce 90 decibel, whereas bus can produce a horn of 100 decibel. Then the heavy trucks, buses, trains, motorcycles, jeeps, other vehicles, they are all responsible for traffic noise. The another one is the industrial and construction machinery noise, the factory equipments, generators, drills, the road rollers, and the similar machinery also make a lot of noise. Building and car park construction and road and pavement resurfacing works are also very noisy. Say for example, a pneumatic drill, it produces a sound of 110 decibels. Then another main cause is public address system. The public system contributes in its own ways towards noise pollution by using loudspeakers for religious functions, birth, marriage, election, or commercial advertising. So usually the bars, restaurants, and terraces that spill outside when the weather is good can produce about 100 decibel. So including the clubs or the pubs. Then comes the household activities. The household activities will contribute for indoor noise pollution, like from the domestic gadgets like pressure cookers or AC, air conditioners, vacuum cleaners, mixers, washing machines. They are the major source of noise at household level. Then the entertainment equipments also at the house like radio, music system, TV. They also contribute to the noise pollution. Then the tanks, the launching of rockets, explosion, military exercise, aeroplanes, shooting ranges are adding to the noise pollution from the defense sector. So these are the main sources of noise pollution. The typical noise level of different sources are given here. So you yourself can actually analyze how much you are exposed to the different noise levels or the different sources of noise pollution every day. So this is the world's noisiest cities. It is as per the ranking compiled with data from many hearing techniques, WHO. So these are the world's noisiest cities, and we can see New Delhi and Mumbai, they come in the 10 world's noisiest cities. So how can we control this? That is one of the main thing as a traffic engineer should look into, because traffic noise is one of the major source of noise pollution. So this video also you can hear a lot of traffic noise since my home is very near to the national highway and it's only morning 6 o'clock. Even then there is a lot of traffic noise created. So in the next video we will be more focusing on the traffic noise and its modeling part, and also we will see what are the methods that we can employ to reduce the noise pollution in cities. So thank you for listening to my video.